Hey there, Cool Fire fam. Welcome to another episode of Cool Fire News, Weekly Edition, the podcast that keeps your mind lit with the latest and greatest in tech trends and everything in between. Today, we're going under the hood of the devices we use every day. We're talking about something foundational, something that makes smartphones smart, computers compute, and systems run. Computer systems architecture. Let's get into it. So, what exactly is computer systems architecture? In its most basic form, it's the design of a computer system. Think of it as a blueprint. Just like an architect plans a house with rooms, plumbing, and electrical wiring, a computer architect designs how the internal components of a computer are arranged and how they interact. This includes hardware, like the processor, memory, and input-output devices, but also the rules and protocols that dictate how software communicates with hardware. In other words, it's the foundation that makes computing possible. Whether you're building a laptop, a smart fridge, or a data center, it all begins with architecture. Now let's break it down. There are three core components in every computer system. 1. The CPU, Central Processing Unit. This is the brain of the computer. It carries out instructions, performs calculations, and manages data flow. Most modern CPUs have multiple cores, which allow them to handle several tasks simultaneously. We call this parallel processing. 2. Memory, RAM, Random Access Memory. Think of RAM as your computer's short-term memory. When you're running apps or loading websites, RAM holds the temporary data so the CPU can access it quickly. The more RAM you have, the more tasks your computer can juggle at once. 3. Input-output, I/O systems. These are all the components that allow communication between the computer and the outside world. Keyboards, mice, displays, hard drives, flash drives, even the internet connection, are all I/O systems. All three of these components work together to make your computer responsive and functional. Let's take a step back in time for a second. Have you ever heard of the von Neumann architecture? This model, proposed in the 1940s, is still the basis for how most computers are built today. It introduced the concept of a stored program computer, meaning the data and the program instructions are stored in the same memory. This made it possible to reprogram machines without physically rewiring them. A huge deal back then. Von Neumann's model consists of a central control unit, the CPU, memory, RAM, I/O mechanisms, and the bus system that connects them. Simple, but genius. It's the reason we can run multiple apps, open different files, and browse the web, all on one machine. Now here's the question. Why should we care about all this? Because understanding computer architecture helps you become a better problem solver. Whether you're a developer, an engineer, or just a tech-savvy user, if you're a programmer, it helps you write more efficient code by understanding how the CPU processes instructions and how memory is allocated. If you're a hardware designer, it helps you decide what trade-offs to make between power, performance, and cost. And if you're just someone who wants to build a custom PC, or troubleshoot performance issues, knowing your architecture helps you make smarter decisions. It's kind of like understanding how your car works. You don't need to be a mechanic, but knowing what's under the hood helps you take care of it better. Let's talk about where things are heading. The future of computer architecture. Here are some of the hottest trends shaping the field right now. 1. Multi-core and many-core systems. Instead of one super-fast CPU, we now have several moderately fast cores working together. It's all about parallelism, doing multiple things at once. This is what allows your phone to stream, browse, and update apps at the same time. 2. ARM architecture. ARM is a type of CPU architecture designed for energy efficiency. It's found in smartphones, tablets, and even Apple's new M-series chips. ARM is challenging the traditional x86 architecture used by Intel and AMD in desktops and laptops. 3. RISC-V, a newer, open-source architecture gaining popularity in academia and industry. RISC-V is super customizable and could lead to more innovation in processors for everything from wearables to AI. 4. Specialized chips. We are also seeing the rise of purpose-built chips, like GPUs for graphics, TPUs for machine learning, and ASICs for cryptocurrency mining. These chips are designed for specific tasks, which makes them ultra-fast and efficient at what they do. 5. Cloud and edge computing. Not all computation needs to happen on your device. With cloud computing, powerful servers can do the heavy lifting, and with edge computing, we process data closer to where it's generated, like in IoT devices and smart cameras. This reduces latency and saves bandwidth. Let's pause and do a little myth busting. You may have heard, more gigahertz means a faster computer. Not always true. While clock speed matters, the overall performance depends on the architecture, number of cores, cache size, thermal design, and how the software is optimized for the hardware. A 2.4 GHz Apple M2 chip might outperform a 3.5 GHz Intel i5 depending on the task. So it's all relative. Time for a little pop quiz. Let's test your knowledge. Question 1. What's the primary function of RAM? A. Store files permanently. B. Perform calculations. C. Temporarily hold data for active processes. Answer: C. RAM holds data temporarily while your computer is working on it. Question 2. What does CPU stand for? A. Central Power Unit. B. Core Processor Utility. C. Central Processing Unit. Answer: C. Central Processing Unit, the brain of the machine. Question 3. Which model forms the foundation of most modern computer architectures? A. Blockchain model. B. Neural network model. C. Von Neumann architecture. Answer: C. Von Neumann architecture. Got them all right? You're a budding system architect already. Before we wrap up, let's imagine a real-world scenario. Say you're designing a smart home security system. You need a camera, input device, a CPU to process the video, RAM to temporarily store footage, flash memory to save files, a network interface to upload footage to the cloud, and maybe even an AI chip to detect motion. Understanding architecture helps you design this system efficiently. You can choose low-power ARM chips, optimize your data flow, and even decide how much local storage you'll need versus cloud space. It's more than theory, it's about building smarter, faster, better tech. Alright folks, that's a wrap for today's deep dive into computer systems architecture. Next week, we'll be looking at the unsung heroes of computing operating systems. We'll explore how they manage resources, keep your apps running, and why you should care about things like memory management and file systems, whether you're using Windows, Mac OS, or Linux. Don't forget to follow, rate, and share Cool Fire News Weekly Edition with your classmates, colleagues, and anyone who's ever wondered what's inside their machines. Until next time, stay cool, stay curious, and keep that processor running smoothly.